Yes, it's a cold one out there. So stay close to the fire. Stay close to the heater. I fired up my fireplace last night. My new fireplace that I've never had before. That was part of my addition to the house last year. So I enjoyed a little warm fire yesterday. Got home from church, fired it up. Just went, man, it feels good. Feels good. All right, 22 students. We've got 12. We're getting there. We're getting there. So I did make it to the movies this weekend. Saw Sarah's Oil. So I don't know if you've seen previews for that, but it's a movie set in 1910 in Oklahoma. It's this little black girl named Sarah that was born like on a reservation or something, and the government gave as part of like reparations or something. It said, and I didn't quite understand exactly what, but gave this little 9-year-old girl 160 acres in Oklahoma. She was born there on the reservation. And everyone thought, well, that's just worthless land anyway. You can't hardly do anything with it. But she was convinced there was oil in that land. And so she's getting oil companies to come drill. And they're like, oh, no, there's no oil. And they say, you can have the equipment. It costs us more to move it somewhere else than just abandon it. So we'll just leave the oil rig there. Then she gets somebody else to come, and they end up getting a sample of something out there and find out it's a really, really good oil, which the oil company actually knew, but they were going to try to steal the land. They told her it was worthless. There was no oil. And the whole thing is about her fighting for her land and the oil company, the big bad guys. So I'm sure there was lots of craziness going on, but it's based on a true story. So it was a pretty good movie. It really was. It was a good movie. And this little 9-year-old girl fighting to keep her land. Her parents are like, hey, we're not even going to pay the taxes on this land next year. We need to sell it. But she's like, nope. God gave me this land for a reason. She fights for it. And pretty interesting movie. Pretty good. So, but you need a good, true story a lot of times to start with if you really want to do it, though. So I love movies that are based on true stories. But some of them work better than others for sure. All right, we got 20 folks in here now. We're only missing a student or two, and hopefully they'll come wandering in here our virtual door. We'll leave our virtual door unlocked so they can come in, and we'll just kind of give them an odd look when they come in late. Let's pull up what we got going here. See what we have this week in programming. Let's see, foundations of programming right here. Let's go to our grade screen. What did we have last week? Oh, the Module 2 project. I didn't turn my Module 2 project in last week. All right, I got to get mine turned in. I've got one written there. But we are starting Module 3 Turtle Graphics. Our first look at graphics. Oh, that's awesome. That means I need to pull up my Turtle Graphics program. But I will find that, and I'll show it to you before class ends here. Let's go to 3.01. We do not have a program this week. So if you're still working on the program for last week, just remember you do have this helper in there. Do you need help with this week's program? Here is this AI tutor that will help you. I was playing with this last week in class, like last Wednesday, Thursday, Friday, when synchronous days. Yes, Reagan.
I'm really picky, but that AI tutor thing actually really helped. So in case if anyone else is wondering if it actually does, it
There
does.
you go. All right. Yes, we got a personal testimony. I know Reagan used it and was able to get her whole project done. It looked great. She turned it in. I'm like, yeah, this is really good. And she used that to help her go through the steps and make sure she was doing the things correctly and that she understood what she was doing. And so this is a good help. If you are stuck or just totally lost or any of that, you can use this to help you figure out how to write the program. So, but this week we do not have a program. We just have looking at Turtle Graphics, which is just the fun. This will be our last. This will get us through Christmas time anyway. Here, this will be the rest of the semester. Turtle Graphics 3.01, and you'll see why we call it Turtle Graphics here. Oh, good. I found my program, so I put it up here. Turtle Power. I mean, let's have an honest conversation about turtles, right? They live to like a super old age. There's turtles that are over 100 years old. Sometimes they can be ninjas, right? We know turtles can be ninjas, and they take the concept of a mobile home to a whole new level. right? The turtles have also made some pretty awesome contributions to the programming world. So we're going to see how turtles have influenced visual programming. So we're going to learn how to explain the role of the Turtle Graphics module, understand how programmers utilize Turtle Graphics for increased productivity, and demonstrate understanding of Turtle Graphics by setting up and moving our tool. Fun. All right, page 2. Turtle Graphics. You've heard of those apps that map out your exercise, right? You can pull up the app and see exactly the little trail that you jogged on. It'll show it on the map exactly where you went. They draw a line that shows the distance and the direction you run or walked or driven. No judgment. That would be me. Those actually work a lot like a set of functions in Python called Turtle Graphics. It's a set of black box functions in Python that allows the programmer to draw on the screen or create images. Like you can make this little thing here with Turtle Graphics. Right away, page 2, we're going to get a little introduction to Turtle Graphics. You have to import the Turtle Graphics. Just like we had to import the math function when we wanted to use power and square root, we have to import the turtle functions. Import turtle. That's all we have to say. Import turtle, and that says, okay, I'll load all the Turtle Graphics. Define main. And when we have Turtle Graphics, you have to name your turtle. So I'm going to name my turtle Tom. This is Tom. Tom equals turtle.turtle. And then we're going to say, Tom, go forward 50 pixels. Then, Tom, I want you to turn left 90 degrees. So this is pixels when you tell it to move forward or backwards. This is degrees when you tell it to turn left or right. And then I want you to move forward another 50 pixels. So let's just run this and see what it looks like. Turtle Graphics opens up an entirely different output window. So when we import this turtle, it imports a whole new graphics window. And the turtle named Tom went forward 50 pixels. So he went forward 50 pixels, and they turned left 90 degrees and moved forward another 50 pixels. So are the results what you expected? It says change the value passed to the forward function. Okay, what if I said go forward 100 pixels and then go forward 150 pixels down here? So now I'm going to go forward 100 and go forward 150. Oh, see, this actually went off my screen up here. I can't even see where it ended up. Let's change that to 120 then. Ah, there we got to the end of it. So by changing the numbers, we can make it go different. And if we can change this 90 degrees, let's say it goes 135 degrees instead. Past 90, 135. Woo, see, it turned all the way back that direction. So you can play with these numbers to get the shapes that you want. Let's look at our second slide. Import turtle, define main, 50. Oh, this does the same thing, 59. Oh, wait a minute. There's the last thing that was loaded. It loaded the graphics thing because it saw the turtle thing, but it didn't do that. Tom is not defined on line 8. It says, what do you mean, Tom the turtle? I don't have any Tom the turtle. Well, we have a problem. Someone put a comment on that line. We didn't name Tom the turtle, and we didn't actually import the turtle to use. We have comments. We've got to take out those comments, and now it runs. Forward 50. Let's see what happens if we put this comment back up on import turtle. Turtle is not defined on line 7. Don't know. What do you mean you're naming some turtle Tom? Yeah, you have to make sure that you've imported the turtle and that you've named your turtle before you can use your turtle. All right, slide 3. Oh, it says, yeah. Import turtle. No comments. It's actually importing it. Tom.turtle in our main function. Oh, now we're going forward 50, turning left 90, going forward 50, turning left negative 185 degrees. We're turning left negative 85 degrees. Going forward 35, turning left 110 degrees, forward 70 pixels, turning left negative 20, and then forward, and that's the end of the function. So let's run it and see what happens. Okay, so there was the 50 degrees right there at the bottom. Then it turned left 90. It went forward 50. Here it actually turned right because it turned left negative 85 degrees. That's the same thing as turning right 85 degrees. In fact, if we want to change that to right and change it to a positive, it should look exactly the same. Now I said turn right 85 degrees. It should look exactly the same. And it does. That's the exact same thing as left negative 85 or right 85. Then it went forward 35 pixels. It turned left 110 degrees right there and went 70 pixels, turned left negative 20 or right 20, and just made a little 20 pixel line. So there we go. Let's look at the fourth slide. Import turtle, define main. Say 50, 90. This is the same thing, I believe. Yep. It says, okay, explore with the turtle by adding forward and left commands to the program. Where will your turtle go? Well, let's turn around. He's about to go off our screen. So let's go tom.left. Let's do like 170 degrees. And then tom forward and like 150. So we're just going to add at the end. Woo! So he went 170 degrees, almost exactly 180 degree turn, but 170, and came all the way back down here. Let's make that 150. So we get it closer to where he started. That's pretty close to where he started. Kind of made a little cartoon nose. Right? So you can play around with this. This is on page 2. In fact, I encourage you to you should come around and play with this and figure out how to draw things. Now let's look. We're going to see some more here. Page 3. Because Turtle can do some things on its own. Python's Turtle Graphics module gives you control of an imaginary turtle who will follow your directions, drawing lines as he moves around. So you can write code to create images. So here's some simple steps. And by the way, when you do the Python API button up here, it'll give you some turtle commands that you can use here. But Turtle Graphics, you click on that, import equals turtle, then you got to name your turtle. Backwards, it can go backwards 50 pixels instead of forward. If you want to go backwards, you can go backwards. Begin fill. If you put a begin fill before you do something and then an ending fill, once it draws a shape, it'll color it in. Circle, it'll make a circle by itself. We'll make a partial circle. You just tell how many degrees of the circle you want. Say like this one, 270 degrees. It didn't make the whole circle, then it changed to something else. Color, you can tell the turtle what color to pick up. End fill. Forward, we saw forward. Hide the turtle so you don't see the little point. You know, our turtle had a little point on the end there. Left at whatever degrees angle. Pin down and pin up. You can have it pick up the pin and move to a different place, then put the pin back down. You can make the pin fatter. See pin size. There's lots you can play with. Right angle. Set heading. You can tell it what degree heading. 0 is going straight horizontal. So it goes at 22.5 degree angle. Set position. Tell exactly where to start on the screen. Look, you can actually make it show the turtle. Shape turtle. So we can add that in there and actually see the turtle. So we'll play with that next time. Shape turtle. Import the turtle. Define main. Got to name your turtle. Raphael. Oh, this is a Ninja Turtle. Raphael, turtle.turtle. Use a function. So import the turtle, define main, name him Raphael, and then start moving around, moving forward, moving left, moving forward. You know, turn left 9 degrees, move forward. The Turtle Graphics module has a lot of useful functions, including forward, backward, left, right. Notice the forward function requires an integer parameter. You got to put a number in there to tell it how many pixels. And there's tons more you want to know for the complex visual programming. So take some time to research the Turtle Graphics module to see all the functions, which is what we were doing right here, looking at all the different things you could do. Show turtle. Speed, you make a turtle go faster. Stamp, you can leave a stamp of the turtle wherever it's at. So different things. What can turtles do? So can turtles draw more than lines? You bet. Add more instructions by using the functions from the Turtle Graphics module. Connect lines, create shapes, patterns, anything you like. Being able to see a visual image of something you program would be pretty powerful. Could lead to some truly inspiring ideas. Look at Picasso. He started with just basic shapes. The rest is history. Programming Spotlight on Seymour Papier. I think Papier says it, but Papert. Most likely to build an army of robot turtles. This co-inventor of the Logo programming language, there's another programming language, was also an early inventor of AI, artificial intelligence. He set the groundwork for what we now know as turtle graphics. He created the Logo turtle, which was a tiny robot turtle that taught children how to program, do program solving. So let's look at another Python guided activity. How many do we have? We have 4 slides. Shapes with the turtles. Import the turtle. Define main. We named our turtle Tina, and we said, Tina, pick up your red marker. Move forward 100 pixels, turn left 90 degrees. Move forward 100 pixels, turn left 90 degrees. Move forward 100 pixels, turn left 90 degrees. So Tina's going to pick up her red marker, and here goes our turtle. There we go. Add code to finish the square. Well, she's already turned left 90 degrees, so really all we have to do is just say, Tina, put my fingers on the right buttons, another 100. Oh, I put it in the wrong place. No, I didn't. Wait a minute. Oh, yeah, I did. I put it in front of that. Good. Got to turn 90 degrees first. Enter. There we go. Perfect. Now I want to do that. What was it? Show speed value. Show turtle. Show turtle. No. I wanted shape turtle. That's what I want. Shape turtle. Shape turtle. But let's do that and see what it. Tina red. Tina dot shape turtle. I want it to actually look like a turtle on the screen instead of an arrow. Look at this. See, it's a little turtle running around. You can make it actually show a turtle that looks like a turtle instead of arrow by saying, hey, but use the shape of a turtle. Use your turtle shape. And we can change it to blue. Make it blue instead. And then, what was that other one I wanted to play with? Begin fill. Was that it? There was a fill up here somewhere. Oh, here it is. Begin fill. And then you got to end fill. So let's go up here. Begin fill, Tina, begin fill. And then at the bottom we can say Tina dot end fill. Then when it gets done, it fills it in. So there's things we can play with. Slide 2. Import turtle, define main. Tori, we're going to name our turtle Tori this time. Tori, get your purple marker. Oh, and we got a second turtle. You can have more than one turtle at a time. So we got a turtle named Tori and a turtle named Trey. And Trey is going to grab a blue marker. And we're telling it a size at the beginning. We'll just say size equals 100, and we're just going to use that variable. So Tori, I want you to make a triangle. I want you to go forward size, which is 100 pixels. So go forward 100, turn left 120, go forward 100, turn left 120, go forward 100. Meanwhile, I also want Trey, after Tori draws her triangle, I want you to go backwards 100 and then turn right 120 degrees, go backwards another 100. Let's see what they do. All right. So Tori made her triangle and Trey's moving backwards. Let's see if we can finish the triangle for Trey. So if we tell him to Trey, turn right again 120 degrees, and then go backwards some more, backward size. See if that finishes it. Perfect. And and the reason they use the variables, maybe you just want to make them smaller. We just got to change this number. Now everybody's going to move 50 instead. So we can just change the size right there. 125. Bigger, bigger, bigger. So yeah, using a variable is handy if you want to be able to change the size of things later quickly. All right, slide 3. Import turtle, define main. Tia, we have a turtle named Tia. And Tia is going to grab a blue marker. And then we got Ted the turtle. Ted's going to grab an orange marker. So we got 2 turtles with 2 different colors. And they're going to draw spirals. Size equals 20. Tia, move forward 20 pixels. Turn left 72 degrees. Move forward again and turn left 120. And then I want it to get bigger. I'm going to add 7 to the side. So now it's going to be 27 pixels. Tia is going to move forward 27, turn left 72, move forward 27, turn left 120. And then we're going to add 7 again and do the same thing. And add 7 again and do the same thing. Now notice that we have Tia and Ted at the same time. So Tia's moving forward 20 and turn left 72. Ted's moving forward 20 and turn left 120. So we got both turtles, Tia forward, Ted forward. And we're going to keep adding 7, adding 7, adding 7, adding 7, adding 7. Let's run this. See what happens. 2 different turtles. See that it looks a little different because Ted's turning left 120 degrees every time. Tia's turning left 72 degrees every time. And every line they draw is 7 pixels longer than the line in front of it. But if you look at what Tia's doing, she's making kind of a triangle that's growing because she's turning the same way every time, and hers is pretty tight together. Since he's turning 120 degrees, it's starting to get like a pentagon that's getting bigger and bigger. So you can sit there and play with the sizes of those. We can start the size smaller, start the size as a 10 instead of a 20, and they'll just bring the scale down on everything. They're still doing the same type of thing. We just started smaller. And you could continue that. We'd use a loop actually and continue that. Let's look at the 4th slide. Import turtle, define main, Terry turtle. Terry, use the color green. Oh, it says do it shape of our choosing. So we hit run, nothing happens because we didn't do anything. One thing you can do is you can say Terry dot circle size. I'll just use the size they have there. They make a circle that has a diameter of 35. Just putting the circle in there. Circle is one of the commands that we find on here that'll just make a circle already of that. Here it is. Circle.radius. So it's not the diameter of 35, it's a radius of 35. So you can just actually just make it draw a circle. So let me open this up, idle window. Here's the program I've written. I was playing with it last year or the year before. I think I played with it both years actually. So you can play around and do some pretty cool stuff. Like this is 142 lines. I made a pretty big one. But import turtle, define main. I've got a turtle named Donald. Black, starts at a speed of 400. He draws really fast. Picks his pin up, moves him over here, puts his pin down, and draws all these different sections. I got all these different sections on here, but I want to show you what it draws. Open this up as big as I can get it. There we go. All right, I'm going to run this program and let you see what my turtle draws here. Little house, a door, put a wreath on the door, put a tree out here. And there you go. Put some windows, a little sidewalk, a little grass line in the back. That's what I drew. Just having fun with the turtle graphics. One thing I was thinking about adding on there is for my tree. Where's my tree? Here's my tree leaves right here. I'm going to say Donald begin fill. I think I want to fill up my tree. Yeah, Reagan.
First of all, that's really impressive. Second of all, can you do like I noticed how you did colors like dark red? Could it also do colors like dark purple and like burgundy and stuff, or does that just like need to be?
Most of it you can just play around with. And let's see. Let's go to the roof. Where's my roof? Instead of crimson, let's do what'd you say? Dark purple. Let's see.
Yeah.
Generally, any color I've typed, it seems to find something on there. Well, that almost looks black. I don't know. Maybe it doesn't have dark purple.
Maybe if we needed to like fill it, then we can maybe seek the line.
Yeah, that's a good idea. Oh, wait a minute. What I messed up something on my end. I didn't underscore end fill. Let's fill up the rough then. Let's if it'll fill because I didn't. Yeah, let's see.
If the color isn't,
let's do the house. Let's do the house because the house is a full square. We'll see if we can fill that in to see if that works.
I'm sorry.
Yeah, go ahead.
If the color isn't like an option, will it just make the color immediately black?
Yes. Yeah. If you don't specify a color, it will automatically make it black.
Okay, and even if you like have a color and it doesn't like necessarily have that option, or does it have options for like?
I'm not sure what you're asking on that. And fill. Okay, we're gonna use. I'm just gonna put purple first on. Yeah, Kaylee.
Yeah, Reagan, that is true. I've done some like playing around, and if you put a color that they don't have, then they just make it black.
There you go. So if you choose color, yeah. So I filled in purple. If I put dark purple, I think it's going to be black. I don't think it has dark. Yeah, see, dark purple, it doesn't understand. All it does. So, but yeah, you can play around with it, and this was just looking at these commands. I was just looking at these commands and seeing what all I could do with it, the fill and the changing colors, and then I got to play with the angles. You know, what angle do I need it to turn to go right here? And I had to have it like for the roof and different areas. Pick the pin up, move to -50, -50. Think of this like an XY coordinate, And I had to play with that number and say, where is -50, -50? And I just draw a line and say, oh, no, I need to be farther down. So I had to lower the Y value down. You know, I had it at -30. No, I need it down to -50. So this is, and it's all trial and error. You draw a line and see that's where you want it. Nope. What do I need to change? So I need to move left, right, up, down. Do I need to be longer, shorter? You know, do I need to? So it's just a matter. It's just playing and playing until you get what you want on there. But yeah. And then I had it over here on the left. After it finishes, it does print out. As it finishes drawing my tree. Merry Christmas to all, because I put a little Christmas wreath on the door, you know, because you can have it print things over here and draw things over here with the Turtle Graphics. So we will start with a Turtle Graphics program, I think next week. This week we just have a 5-question quiz over there. So let me go. That is the end of the lesson. This week we just have a 5-question quiz. Python has a library of books, including Turtle Graphics manual. True or false? What does Python provide in its built-in function library? Computer books, hardware manuals, pre-written code, or test questions? So anyway, 5 questions here about this lesson. And but yeah, you can certainly have some fun with this going forward. Just you're limited by your imagination again. You know, draw, and you can spend hours playing with the graphics and just figuring out what you want it to look like in the end, and making it work. So I may have to. Maybe every year I'll take this program and just add to it and just make it more and more elaborate. So far that's pretty good. I'm happy with what I got going there. And you know, maybe I need to make one for a different season. Maybe I need a Thanksgiving one or something. Maybe I try to draw a little table and put stuff on it. What do you think, Reagan?
That would be extremely cool if you just slowly add on to the program.
Make it bigger and bigger and bigger and more.
Yeah, and not even that, just like adding details and everything. That would be really cool.
Yep. Maybe try to figure if I could draw a little bird in the tree or something.
Yeah.
I don't know.
Like once a week or something, and then by the end of the week you can be like, "Oh, look what I did," and then
Yeah,
that would be
yeah.
really cool.
Put some little decorations out in the yard or some little bushes or yeah. So it's fun. You can just get lost in there, spending all kinds of time. It's really fun. But and you can start playing with that now because you have some of the basic stuff in our lesson. Go those Python guide activities, copy those, put them in an idle window if you want to where you can make it a little bigger to see it and start playing with that and kind of get ahead on and look at next week's lesson if you want to because we're going to be writing a program if you want to get a little head start on it. So the nice thing is next week's lesson will lead right into Thanksgiving. So you don't even you have 2 weeks really to play with it before you got to turn it in if you want to. But, don't work a lot over Thanksgiving. Enjoy family time. All right, guys, that's all I got for you this week. You can kind of see what's coming up. We get to play with some fun stuff coming up. Yay. And so, all right, guys, we will talk to you later. Have a great week. Let me know if you got questions. It is an A-Day Friday.